Okay, so the map is showing the locations of 4 fire stations, and it's important that you know which one is closest to every location. So the first one said which one is closest to 6-3. That one just seems obvious, right? 6-3. So that would be C. And then 4, 6. That one you might have had to do a little bit of math. You can see clearly that the distance from A is 3, but for the distance to B, you would need to do Pythagorean theorem, right? And you should find with the Pythagorean theorem that you're going to get 2 point something. Did anybody get something? Or did you just see that it was closer? What's that? Distance formula, right. Distance formula is an application of Pythagorean theorem. That's good. What'd you get? What? Oh, root 5?
Yeah.
Square root of 5, which is 2 point what?
2.23.
2.23, okay. So, closer to B than it is to A, right? Yep. And if it were an IB, like a question on an IB test, then you would need to show the math to show that it's closer to B than to A. So you could use distance formula or Pythagorean theorem there. Okay. The station master at fire station D wants to know the region of the city that's closest to his station. What does this region look like? Did anybody try to draw the region that was closer to D than to any other station? Raise your hand if you tried to draw it. Good. Only one person? Did you describe it with words? Did you just ignore it? Okay, so if you're thinking about this, you want it to be closer to D than to A, right? So you can go halfway between them. So something like that. And then closer to D than C. So let's go halfway between those. Like that, right? So just eyeballing it, it might just be something like that bottom left corner, right? That bottom left corner is closer to D than anything else. So you can either draw something in, and we're not being exact yet because I haven't taught you that. You're just trying to use your intuition. Or you could just say the bottom left corner. Okay? If we could improve the map to make it easier to determine the fire station. Oh, how could we improve the map? Did anybody have an idea? Say it again? Add lines to it? Yeah. So we could add lines to it to create the different regions. I had another student say, well, it would be important to know where the roads are, and like that's certainly true. But as far as applications to the Voronoi diagrams, yeah, we could create regions for each station by adding lines. All right, and then it says a new fire station is to be built within the city grid. To maximize efficiency, the new fire station should be built as far as possible from existing stations. Where should it be built? What ideas did you guys have? Did you have a coordinate where it should be built? What did you think, Hayden?
9,6.
So 9,6 was actually one of the spaces I was looking at originally too. Who had a different idea? Do you guys agree 9,6 is pretty far from everything? Okay, but if I changed the wording a little bit and I said it had to be within this region that connects the fire stations, can you reconsider it? I didn't say that before, so that would make Caden's answer a really good one. But if I'm telling you now it has to be within the region of connecting the fire stations, see if you can find a coordinate that might look good. You like 4-4? Simon, you like 4-4 also? Yeah? Anybody else think 4-4 looks pretty good? Yeah, so basically somewhere in the middle of the stations, which might be 4-4. And that's only because I gave you that extra rule that it had to be within the stations. Otherwise, 9-6 would have been a really good answer. Middle of the stations, about 4-4. Okay. All right, let's learn about Georgie Voronoi. Georgy Voronoi was a mathematician, and he's from Ukraine, and he invented the Voronoi diagrams. I find it interesting that his name is spelled this way and the diagrams are spelled that way. But I don't know. I don't know a whole lot about him. I just know how to draw his diagrams. Consider the map from the warm-up. For each station, there's a region that contains all the points that are closer to that station than any other. So you can see here, the regions are drawn for you. Okay? We will learn how to draw those regions. The Voronoi diagram alongside illustrates these regions. Notice each region contains one fire station. This is the closest fire station to every point in the region. So if you have this map, it's really easy to see that if you were at, let's say 7, 5, and it was kind of hard to see if you were closer to B or C, you could see really quickly that you were closer to C because you were in its region. So we have some vocabulary to learn down here. In a Voronoi diagram, important locations are called sites. And each site is surrounded by a region or a cell. And then the lines that separate the cells, these lines that separate them are called edges. And then you might not be surprised to learn that the edges meet at points that are called vertices. So if you're at a vertex, this one's weird because this has this like little area between the two, but pretend that they all met at this one vertex. If they were to all meet at this one vertex here, then that point would be equally distant from all the sites. Anywhere that's on this edge between C and D is equally distant from C and D. So if you happen to live there, then you could reach either of those fire stations. All right, ready? Let's turn the page. All right, consider this Voronoi diagram for sites A, B, C, and D. How many cells does the diagram contain? So the cells are the regions. What do you guys see? 4 regions, yeah. 4. All right, so yes, 4 cells. All right, how many vertices do you see? Just 3, yeah. 1, 2, 3. All right, so then to identify the sites closest to these points, you're just looking inside of the cell to see what is the site in that cell. So for example, 2, -3 is here, and that's in the same cell as B, so it's closest to B. Do the other 2. Okay, let's look at 1, 5. 1, 5 is closest to which site? Okay, good. And -1, -2 is right on this edge, and that edge is separating what 2 sites? Separating C and D. So we would say it's equidistant from C and D. Yeah. So you could just say C or D. They're both good. All right, we have an edge all the way up here, and we want to see if you were on that edge, what would you be closest to? So Sophia suggests A and B evenly, and Sally's agreeing. Anybody else? Yeah? So you might need to do a little distance formula to convince yourself, but I do have A and B down. But if you do distance formula and prove me wrong, then I want to know about it.
Just because it says the points that lie on the edge circled, like the edge could also in the circle could also be talked about.
Oh, I see what you mean.
Yeah.
I think they're referring to this one, but I understand because Caden's pointing out like this corner of the triangle is also circled, yeah. But I think they're just referring to this one. So I'm gonna say equidistant from A and B. All right, And now we're going to be talking about perpendicular bisectors. So if you were here last class and you practiced parallel and perpendicular lines, then that's where this comes in. All right, so in geometry class, we learned about the perpendicular bisector. Perpendicular bisector of AB is a line that is perpendicular to AB and passes through the midpoint. To draw Voronoi diagrams, you need to draw perpendicular bisectors. So you need to know how to find the midpoint, and you need to know about perpendicular slopes. All points on the perpendicular bisector, so let's look at a random point. Here's one. All points on the perpendicular bisector are equidistant from A and B. No matter where you are on the perpendicular bisector, you will always be the same distance from A and B. The perpendicular bisector divided the plane into two regions. On one side of the line are the points closer to A, and the other side of the line are the points that are closer to B. Okay. For a plane that consists of two sides A and B, the Voronoi diagram simply consists of the perpendicular bisector of AB. So even if AB is not drawn, you could draw it and then create its perpendicular bisector. And that is much easier to do on a plane, like a coordinate plane. So you'll notice most of our problems happen on a coordinate plane. All right, so when you're done with that, turn the page. We've got one more section of reading, and then we're going to do some constructing. And if you would like a ruler, honestly, not necessary, but nice when you're drawing lines. I might still have some on that top shelf. Okay, next page. So for a plane with three sides, A, B, and C, we draw the perpendicular bisectors of AB. So here's AB, and here it's perpendicular bisector. AC. So here's AC, and it's perpendicular bisector, and BC. So here's BC, and it's perpendicular bisector. If they're not collinear, these three lines will meet in a single point that's equidistant from A, B, and C, and this point is a vertex, so there's only one vertex here. Notice only a section of each perpendicular bisector is included. So these parts with the dashed line, those aren't actually included. You would, if you had drawn the perpendicular bisector, you would erase those parts. All right, so let's do a very simple one in number 2. We're going to graph these points, and then we're going to construct the perpendicular bisector. So let's graph A at -1, -2, and B at 5, 0. Let me get a better pencil. Now, if you want to, you can connect them, but it does make your graph a little bit confusing in the end, so you don't have to connect them. If you do connect them, though, erase that when you're done with it. This was A, and this is B. All right, so perpendicular bisector, we need to be able to find the midpoint, and then we need to find the perpendicular line through it. So the slope of AB is up to and over 1, 2, 3, 4, 5, 6. So 2 over 6, which is 1 over 3. So what slope would be perpendicular to 1/3? Good. So you have to do the reciprocal and you have to take the opposite. So it would be perpendicular slope is -3. So we're going to be drawing a line with a perpendicular slope of -3, and we also need to find the midpoint of AB because it's going to go through that midpoint. So the midpoint of AB is just the average. So you average the x's, -1 plus 5 over 2, and you average the y's, -2 plus 0 over 2. So that gets me 4 over 2, which is 2, and negative 2 over 2, which is negative 1. So I found the perpendicular slope, I found the midpoint, so I'm going to graph the midpoint and draw that perpendicular slope. I'm going to pause for a minute because I see some people processing. All right, so my midpoint is 2, negative 1, so 2, negative 1. And when I graph it, it definitely looks like the midpoint. And then I need to do that perpendicular slope of negative 3. Now, it's not a fraction, so if I'm using rise over run, I should make it a fraction. It should be negative 3 over 1. So I'm going to go down 3 and over 1. And then I can go backwards too. I can go up 3 and back 1. And then you want to draw that line to separate them. Okay. This is a very simple one because we only have 2 sites. So this half of the graph is closer to A, this half of the graph is closer to B. Let's look at B. And I'm going to encourage you to work ahead of me, but we're going to start by graphing the sites. Negative 5, 2. Yeah. 3, negative 4. Negative 3, negative 2. That's about right? Yeah. Okay, so we have a bit of work ahead of us. I'm going to start with, actually I don't think I want to start with AB because that one, they're so far apart. I'm going to start with AC. So, slope AC is 1, 2, 3, 4, negative 4 over 2, which is negative 2. And so my perpendicular slope is the opposite reciprocal, 1/2. And then midpoint AC is going to be the average. So negative 5 plus negative 3 over 2. And then 2 plus negative 2 over 2. Negative 4, 0. Now don't do yours in pen because there'll be pieces that we erase, but I'm going to do mine in pen because I just happen to know where it is going to erase. So negative 4, 0 is here. Eyeball it. It looks like the midpoint, right? And then I'm going to do a slope of 1/2. So up 1 and over 2. Now you can go all the way across your page if you want. I'm just stopping here because I can't erase my pen. All right, I'm going to ask you to try to do the same thing for CB right now, CB. Don't do AB yet because they're so far apart. We'll do that later. Do CB next. All right, so let's take a look at CB. For CB, I got a slope of negative 1/3, so perpendicular is 3. Did you guys get that? And then for the midpoint, I got 0, negative 3. Okay, so 0, negative 3 is here. And then I'm going to do a slope of 3 over 1, so up 3 and over 1. Okay, thank you. All right, So some of you guys have your lines that keep going like this, and that's totally fine. A little spoiler, I'm going to erase those, but you're using pencil, so that's fine. So right now what I have is I have the perpendicular bisector of AC and the perpendicular bisector of CB, and now I need to look at AB. All right, so for AB, slope AB, I got -3/4. I got -6/8, which is -3/4. And so then perpendicular to that would be 4/3. So -6/8. And then perpendicular is 4/3. And then the midpoint of AB is, I get -1, -1. I'm running out of rooms to show you the steps, but I think you guys got the steps. So I just averaged the A's and the B's, and I got -1, -1. Okay. But notice -1, -1, it falls in this sector C, right? That's definitely closer to C than to A and B. So I'm going to use that point, but I'm going to not use that part of the line. So when I use this point, I start at -1, -1, and I do my perpendicular slope that's up 4 and over 3. And then up 4 and over 3. Okay, and I'm using a pencil this time because I'm going to erase a lot of this line. Okay. So this part of the line here is useless. This part of the line is actually closest to C. It's useless for separating A and B. So I don't actually need that part of the line. The part of the line I want is this part of the line at the end, separating right there. I'm going to erase these little lines here, and what I kept is I kept this piece of the perpendicular bisector of AC, I kept this piece of the perpendicular bisector of CB, and then this is separating A and B. All right, this Voronoi diagram is missing an edge. Complete the diagram and find the equation of the missing edge. So remember last class we talked about the equation of lines. They are on the board there behind Andrew and Assam, the different forms of the equation. It didn't even say what form to use. I did slope-intercept myself. It's my favorite, but you can do any form. All right, so let's look at the diagram. What are we missing? The perpendicular bisector of what two pieces? BC, yeah. So you need to construct the perpendicular bisector of BC, and then complete the Voronoi diagram, and then you're going to find the equation of that missing edge. So I want you to give it a try before I go over it. Okay. Slope of BC is 1/2, right? 2/4, which is 1/2. And so my perpendicular slope is -2, the reciprocal opposite. The midpoint of BC, it didn't give me the point, so I need to either eyeball it, which is not very mathematical, definitely wouldn't give me points on a test, or average the points, so I need to actually know what the points are. So B is -2, 1, and C is 2, 3. Okay, so then I'm going to average these, -2 + 2/2, and 1 + 3/2, and I get 0, 2, right here. All right, and then I'm going to do that slope. I'm going to do the down 2 and over 1. I know that my line's going to just be up here, so even if I sketch it in over here, I'm going to be erasing part of it. So down 2 and over 1, up 2 and back 1. So I have that, but I don't need to be going into the next cell, so I'm going to erase that part and just use that part. Right there. All right, did anybody write the equation of the line yet? One person did. Anybody else? Nope. 2 people, 3 people, 4 people did. Very good. Sophia, what format did you use?
Y equals mx plus b.
Uh-huh. And what did you write?
Negative 2x plus 2.
Okay. Again, is that what you got? Yeah? Asan and Sally, did you guys get y equals negative 2x plus 2?
Yeah.
Or did you use a different format? Did you do point slope or standard? No? Okay. So if you're going to use y equals mx plus b, the m is the slope, which we already found, negative 2. And the b is the y-intercept. And if you're looking at the graph right here, the b is 2 because it's right here. Okay? We're using the perpendicular slope. That's the m, right? And then we're using the y-intercept for the b. And don't be embarrassed. Only 4 people even tried to do this, so you should be happy.
Wait, so how would you find the y-intercept if you couldn't just see it on the
What you would have to do is you would put the m in, and then you would choose a different point on it. So say I didn't know the y-intercept, but I knew this point. Then I would substitute those for x and y and solve for b. That's one way to do it. All right, so y equals negative 2x plus 2. That's my equation. All right, did anybody work ahead on 4 yet? Nice, Kaden. This is your unit.
Don't say that, you'll be
There's no jinxing. Find the coordinates of the missing site x in this Voronoi diagram. Do you guys see the cell that doesn't have a site in it? Yeah, it's like on the left, right? Okay, so looking on the left there, we need to find that cell that's in the middle. It's going to be on the perpendicular bisector of A in itself and D in itself. So what we're going to do is we're going to draw a line that's perpendicular to this that goes through A. So draw this perpendicular here. And then we're going to draw a line perpendicular to this one that goes through D. Now for this one I have to do some counting. What is the slope of this line? It's 1/3, right? So I need to do a slope of negative 3 over 1. So from D, I'm going to go up 3 and back 1, up 3 and back 1. Okay? So I drew the perpendiculars to each of these perpendicular bisectors that goes through the point. Go ahead.
I'm confused on what we're doing.
All right. So we found the line that was perpendicular to this edge and then went through A. So draw a line through A, perpendicular to the edge, and the slope is undefined because it's perpendicular to the 0 slope. And then we're going to draw a line through D. Perpendicular to the edge. And because this slope was 1/3, we did a slope of negative 3. And then the lines intersect at x, which was negative 3, negative 1. I see people writing, so I'm going to give you another minute, and then I'm going to turn the page. But feel free to read. Okay. All right, nearest neighbor interpolation. So suppose Ted is interested in the rainfall in his city and he set up rain gauges at several locations to measure the rainfall. He wants to use these measurements to estimate the rainfall in other parts of the city. On a two-dimensional grid, the process of using values of a variable at known points to estimate a variable's value at other points is called interpolation. And we're going to be doing a special kind of interpolation called nearest neighbor interpolation. Which is a very simple method that's going to use these diagrams. So to estimate the value of a variable at any point, we use the variable's value at the nearest known data point. So we don't average data points together, we just try to find the nearest neighbor. Unless they happen to be exactly between two neighbors, then we average them. So we do construct the Voronoi diagram with the known data points as sites, and then we draw the edges so that we can tell where the nearest neighbor is. So Ted measured the rainfall at 3 locations, A, B, and C, and here are the results. So A was 12 millimeters of rain, B was 7 millimeters of rain, and C was 15. So you're going to find each point, and if it's in the cell with A, then you're going to say, oh, 12 millimeters. And if it's in the cell with B, then you're going to say 7 millimeters. And if it's on an edge, then you're going to average the two to find out the millimeters of rain. So go ahead and do part 5.
How would you average it?
And then down here, I have E. What's closest to E? Is it A, C, or D? They're all the same. So I can do AE. That's 1 and that's 3. So 1 squared plus 3 squared, which is root 10. What's root 10 going to be about? More than root 5 for sure.
3.16.
Okay. So which of these will be farther from one of the sites? E or F? E. So E is farther from the sites just by doing Pythagorean theorem. Just 1 squared plus 3 squared equals the square of AE. I get root 10 versus root 5. You can draw the circle in. So the circle is going to go through these 3 points because they're all the same. And any point that is 3, 1. So I just draw in, starting here, I'm going to draw in all the points that are over 3, up 1. It's just going to help me draw my circle. Some of you don't care as much if your circle looks that great. I kind of care.
How'd you get 3 over on YouTube?
Oh, give me a sec. I'm working on my beautiful circle. Okay, so I noticed that all of the sites had a distance from E that was 1 direction 3, 1 direction 1, right? And so I continued doing that all the way around the circle to find more points so I could draw a pretty circle. So for this circle, we're going to identify it by its center and its radius. So its center is 1, 0. And its radius was square root of 10, which we'll leave it as root 10, because that's the exact answer.